Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we have this problem to solve. In this problem it is said that block A and B each have a mass m. Determine the largest horizontal force P which can be applied to B so that it will not slide on A. Also, what is the corresponding acceleration? And the coefficient of static friction between block A and B is mu s. And further it is said that neglect any friction between block A and the horizontal surface. So now both of these block A and block B need to move with same acceleration, right? So both blocks will have same acceleration, and we have to find this force P so that both the blocks move together and so that this block P does not slide on this block A, right? So now if I consider both of these blocks together, right, so here we will have the normal force, right, like this. Similarly, the weight of both the blocks will be acting vertically downward, right, and there is no friction between the block A surface and this horizontal plane surface, right. So again, if we apply the equation of kinetics to both the blocks together, if we apply the summation of forces along x equals to max, right, and both the blocks will have same acceleration, and let's say both the blocks have acceleration of ax equals to a, right. So if this is my positive x and positive y direction, so as we can see that we have only this p force which is acting in the negative x direction, so I will write minus p, and this minus p will be equal to the acceleration, right, that is mass times acceleration. So both the masses of both the blocks, right, so the masses of both the blocks are each block has a mass of m, right, so both the blocks will have a mass of 2m, right. So this will be 2m and ax is a, right. So if we write the acceleration from this, let's say if this is my acceleration, so acceleration is equal to minus p divided by 2m, right. So the minus sign indicates that the acceleration is in the negative x direction, so this is our acceleration, right. So this will be ax equals to a. So acceleration will be equal to minus p divided by 2m, right. So this is our acceleration. Now to find that force P, if I only consider that block B, so this is that block B, and here we have that horizontal force P, right, and its weight will be acting vertically downward, and its weight will be equal to m times g, right. The mass of this block B is m, right, so this will be m times g, and here we will have that normal force which will be acting by this block A on block B, right. So let's say this is my normal force, right, and let's say that here we will have that static friction force, right, this is that static friction force, right. So this will be equal to mu s times n, right. Now if we draw a horizontal line here, if I draw a horizontal line here like this, so this surface is making some angle theta, and if I draw a vertical line here, right, so this force, this normal force is perpendicular with this line, and this vertical line is perpendicular with this line. So this means that if here the angle is theta, right, then this normal is also making angle theta with the vertical line, right. So this is that normal n which is making angle theta with the vertical line. So we can resolve this normal into its components. So we will have two components. We will have this normal force will have one component like this. So this component is the cos component. We can write that this is n cos of theta, and similarly this normal force will have one another component which will be acting in this direction like this, right. So this one will be the sine component, right. So this one is n sine of theta, and similarly this mu s n is parallel to this inclined surface, and this inclined surface is making theta. So this mu s n will have two components. It will have two components. If this is mu s n, so this will be one component of the this friction force. This is mu s n. So if this is theta, right, if this is theta, then this is also theta, right? So this one will be the cos component, this is mu s n cos of theta, and it will have one component like this. So this one will be the sine component, so this one will be mu s n sine of theta. And this block B need to move with that same acceleration, ax equals to a. So again, if this is our positive x and y direction, right? So if I apply the summation of forces along y equals to may, right, for block B, right? So as we know that both of these blocks only move in the horizontal direction, that is in the x direction. So this means that acceleration in the y direction is 0. So this means that the summation of forces along y will be equals to 0. So now as we can see that we have this cos component of n acting in the positive y direction. So I will write plus n cos of theta minus this mg and minus this sine component of mu s n, right? It is also acting in the negative y direction. So I will write, let me write that mu s n sine of theta minus mg. So this will be equal to 0, and we can bring this mg to the other side of equation. So we will have it like this, and if I take n common from both of these terms, so this will be cos of theta minus mu s sine of theta equals to mg, or we can write that n is equal to mg divided by this term, right? So this is cos of theta minus mu s sine of theta, right? So this is the normal force which is applied by block A on this block B, right? Now if I apply the summation of forces along x equals to max, right? So as we can see that this sine component of this normal force is acting in the positive x direction. So I will write plus n sine of theta plus this cos component of mu s n, that is the friction force. This is plus mu s n cos of theta and minus this p force, right? Minus this p force which is acting in the negative x direction, and this will be equal to m. The mass of this block B is m and ax is a, right? Both the blocks are moving with that same acceleration, right? So now as we know that this acceleration is equal to minus p divided by 2m, right? So I can bring this p to the other side of equation, right? So this will be plus, this will become plus p, right? And this will be n sine of theta plus mu s n cos of theta, and this is m, and in place of a we can write that minus p divided by 2m plus p. So m will cancel out and we will be left with minus p divided by 2, right? So we will get, this will become p divided by 2, right? And I can take n common from both of these terms, right? So we will have it like this, right? And as we know that n is equal to this thing, right? So we can write that this will be equal to sine of theta plus mu s n cos of theta into that n, right? And n is mg divided by cos of theta minus mu s sine of theta, and we can multiply both sides by 2, so this will become 2mg, right? So now we can write this p force, that horizontal force, equals to 2mg sine of theta plus mu s cos of theta divided by cos of theta minus mu s sine of theta. So this is that required horizontal force P, right? And similarly we were asked to find the acceleration, right? So we know that acceleration is equal to, we can write that acceleration is equal to minus p divided by 2m, right? Or we can write that this is 1 divided by 2m we can write it minus 1 divided by 2m into p, and this is that p, right? So let me write that p here, right? So that p is 2mg sine of theta plus mu s cos of theta divided by cos of theta minus mu s sine of theta, right? So 2m will cancel out and we will be left with this thing, right? So this is minus g into sine of theta plus mu s cos of theta divided by cos of theta minus mu s sine of theta, right? So this is the acceleration in terms of all the given parameters, right? So this is the acceleration and this is that force p which was required. So this is the solution of this particular problem. I hope you people would have understood this problem solution. Kindly subscribe my channel if you haven't subscribed it yet. Also like my videos if you people want me to solve such more problems.